Starting with post-combustion capture, this method comes into play once the fossil fuels have been burned. The exhaust gases, also known as flue gas, are then passed through a solvent that absorbs the CO2. This CO2-rich solvent is subsequently heated to release the CO2 in a concentrated stream, ready for storage or utilization. One of the advantages of this method is that it can be retrofitted to existing power plants. However, it comes with its fair share of drawbacks, such as significant costs and a potential reduction in the plant's energy efficiency. Moving on to pre-combustion capture, the fossil fuel is first converted into a mixture of hydrogen and CO2 through processes like gasification or partial oxidation. The CO2 is then separated from the mixture and the hydrogen is burned, resulting in significantly less CO2 emission. This method boasts potential efficiency that surpasses post-combustion capture. However, it requires extensive changes to the power plant's infrastructure, making it more suitable for new builds rather than retrofits. Lastly, we have oxy-fuel combustion. In this method, instead of burning fuel in air, nearly pure oxygen is used. This results in flue gas that's mostly CO2 and water vapor, simplifying the CO2 separation process. The method is renowned for its high CO2 capture efficiency, but it's not without its challenges. It's expensive, as it necessitates an air separation plant to produce the oxygen. While each of these methods offers a unique approach to capturing CO2, they all share common considerations. Cost, for example, is a significant factor. Regardless of the method, carbon capture is an expensive addition to power plants. Then there's the question of storage. Once captured, the CO2 needs to be transported and stored, often in geological formations underground or used in processes like enhanced oil recovery. Finally, while these methods exist and are in use today, scaling up and reducing costs remain essential for widespread adoption. So, to recap, we've explored the three primary methods of CO2 capture from power plant emissions: post-combustion capture, pre-combustion capture, and oxy-fuel combustion. Each has its unique processes, benefits, and challenges, yet they all share the common goal of mitigating the environmental impact of fossil fuel-based power plants. As we continue to innovate and refine these methods, we move one step closer to a cleaner, more sustainable future.